Hello all. Uh, this is one more aggregate planning or sales and operational planning problem. This problem is different than the other kind where you have manufacturing and you have inventory and back order. In this problem, it is a service situation where there's no inventory possible. This is an example of municipal division road maintenance where the manager has determined that you need 6,000, 12,000, 19,000, and 9,000 hours of labor for their road maintenance for the next 4 quarters. At this point, they have 11 workers, and each worker can contribute 500 hours. Their quarterly wage per worker is 6,000. And if they have overtime situation, they have to pay $18 per hour. Workers are limited to 20% overtime per quarter. And the cost of hiring is 3,000 and laying off is 2,000. So they want us to do this problem in multiple ways. The first one is they want us to do it using a level plan. Then they want us to use chase plan, and then see if we can do any better on our own mix strategy. So I have prepared an Excel spreadsheet a little bit to begin with. So this is a level plan. You have situation where the labor demand 6, 12, 19, and 9,000 is put down here 4 quarters. At this point, you have 11 workers, and we need to figure out how many workers you need to hire. The point to remember is since there's no inventory and there's no back order, you will probably use the maximum value and plan for that number. Okay, so you need 19,000 is the maximum of the numbers. So you say a worker needed for 19,000, and let's assume that the workers will work all of them. They can put in their full overtime. So number of workers needed will be this number, or actually, if you want to be safe, write a generic formula is maximum of these 4 numbers, just in case you decide to change the values here and there. Okay, divide that by, you have to divide it by 500 plus this 100 overtime, and again, I have put these numbers from the table in one area on the Excel spreadsheet. So 500 is the number of hours they can work. They can do 20%, and 20% of 500 is 100. So again, I didn't put it in this 100. I just wrote a formula here. Let me just show you. I wrote a formula here, which is this times this number. Okay, so let's begin. And 6,000 is the cost of worker. $18 per hour is the overtime cost. Hiring and layoff cost is given here. So let's figure out the maximum, the minimum number of workers they will need. So that will be based on maximum of these numbers. Formula is going to be maximum of these numbers divided by the sum of this plus this. So each worker can contribute up to 600 hours if they were working fully overtime. And if you do this number, it comes out to be 31.66. And you need to have a whole number. So I'm going to take this formula and modify it again. And I will write down is equal to basically round up. And to nearest whole number. Why am I doing that? If I change the formatting and make it look like 32, it will still retain 31.66. So you have to write the round up formula and 0 decimal. Okay, so that will give you a whole number. So you need 32 workers every quarter. So I'm going to take this number. Excuse me, I moved too fast. Okay, and don't forget the function for, which is anchor it and copy it across. So every time you will have 32 workers. Now, how many hours can they contribute during straight time? Well, let's figure out. So each of the 32 workers could contribute this number, 32 of them, times this 500 number, and function F4, anchor it. So they can contribute 16,000 hours, it looks like. And that looks okay, all right? Now, the only trouble is that you have plenty, you don't have plenty, you will have to run some overtime, and you don't have to run overtime in Q4. Okay, so overtime needed is going to be, what is the amount of overtime needed? This minus this, obviously each time is going to be a negative number. You know that you don't need negative 10,000, so you make it 0, because you have to still pay the worker for full time, even though they are underemployed in Q1. You have too many workers, but you are using level approach. So I'm going to write a little formula here, make it maximum of this number, and if this number is negative, you put in 0, and now you write a formula here and copy it across, and there you go. Okay, so number of overtime. By the way, I just want to put one more line here, which is I want to make sure that I do have enough availability of hours. So max OT allowed. Just to make sure that, max OT allowed is okay. So max OT allowed, I already had this, okay. Delete, oh, okay, all right. So max OT allowed. So number higher, okay. So max OT allowed. Max OT allowed is going to be basically the number of workers times, remember that 100 is the maximum you are allowed, and anchor it, and let's go across. Your goal is to make sure that you are allowing enough overtime, and it looks like you do. You're okay. This is the only period when you need overtime. You need 3,000 is what you need. Maximum allowed is 3,200. You are well within the limit. Next, you need to hire people. So hiring is, you need 32 people minus what you had in the last quarter. This is okay, but sometimes you can have a negative number, remember, as we discussed in class. So I'm going to just put the max function just to be safe. So it never gives you a negative number. And number of workers laid off is going to be this minus 32. Obviously, you're not laying off negative workers, so you have to put the same max formula, which is max zero. And so you're not really laying off anyone. Okay. Now you can figure out the total cost. All right. So we need to worry about the worker cost. How many workers are you employing? Workers hired. Actually, the more accurate word should be really workers employed. Okay. So if your number of workers you're employing is 32, and all right, so total quarterly workers, I'm going to just sum them up. 32. So 128 workers are employed, quarterly workers, I'm converting them into quarters, 128 quarters of worker. And overtime cost we'll have to calculate. So let's calculate the total. Control C, I'm copying the formula here. And so you need total 3,000 hours in your plan. And then how many hires and how many layoffs? This is the plan. All right. So now you need to figure out the total cost. So this is going to be each quarterly worker is paid 500. So take this number times 500. Okay, and then number of overtime is going to be this number times $18. And then cost of hiring, this number times 3,000. And I'm just going to copy this formula down just in case. Okay, so there's one little issue here. This number is wrong, and I'll tell you why. Why it is wrong. I'm multiplying it by 500. Now, really, I should multiply it by the cost, not the hour. So remember, each worker. So, pardon me. This should be 128 times. Each quarter, you're paying $6,000 per worker. This is the number. That's why we were getting a little off number. So this is the cost, $885,000 with this plan. Okay, this is the level plan. Now, they also want us to do the chase. Okay, how many, you're constantly hiring and firing workers. Well, if you have the formula here correctly, I'm going to just copy this and create a copy, move to the end. Okay, and I'm going to call it not level, but I'm going to call it chase approach. Okay. So now all you do is you say, well, I'm going to constantly change my hiring. So I'll keep all the formulas. I don't want to delete them. Okay. So I just need to figure out how many workers I need to hire every quarter. And the plan is, I will assume that I'm not using overtime. Okay. All right. So take this number. Okay. And number of workers needed is going to be, let's figure out. This number divided by each worker can contribute 500 hours. It gives you 12 number. It is a good round number, but let's not take a chance. Let's write down a round up formula just in case it's not a whole number. It will round it up to the nearest number. So we got that number of workers needed, and I'm going to copy this across. Copy cells. And I know what happened here because my B17 it's good to make a mistake. My B17 was not function F4. So anchor it and that problem will disappear. So it is dividing by 500 every time. There you go. So it tells you you need 12, 24, 38, and 18 workers. How many hours can they contribute? These are the number of hours they can contribute. So will you need any overtime? No. Okay. Because every quarter they are producing whatever that is needed. But you have to constantly hire and fire workers. Notice this one. First quarter. And the beauty is you wrote the formula. It is doing all the calculations for you. First quarter, you hired one worker. Second quarter, you went from 12 to 24. So you hired 12 workers. Third quarter, you went from 24 to 38. So you hired 48 workers. And fourth quarter, you went from 38 to 18. You hired 20 workers. And if you do all the it does the calculation automatically, all of it, because you wrote the formula in a very generic, correct format. So in second case, when you're using chase approach, your cost is much lower. If you recall, when you were using level, your cost was 885, I believe, 85,000. Okay. And now your cost is 673.00. Now, they want to try it out again. Maybe it's see if you can reduce the cost further. So I'm going to just create a copy of this file again. Move to the end, create a copy, and I'm going to call it mixed approach. And let's see, I'm just trying out, is there anything I can do? It looks like that I can, can I play with a fewer number of people? I remember there were 32 workers I needed, right? In the previous one when we were using maximum overtime. So you are going to reduce some hiring and laying off if you can just cut down, because you will not go from 24 to 38. Maybe you can reduce the cost, because cost of hiring and laying off is like 3,000 plus 2,500. Let's see. Can I change this to, like, let's see if I can I make it 30 and see what happens. Oops, overtime needed is 4,000. Overtime allowed is, this is where I have an issue. This everywhere is okay, but I can't have 30 workers. Do you understand why? Because with 30 workers, my cost is lower maybe, but I see that I need a lot more overtime than I'm allowed. I'm allowed only 3,000 because each worker can do only 100 hours. So 30 times 100 is 3,000, but my overtime need is 4,000. So you say, well, I have to hire more workers. Let's see, 31. 31. I'm still off. You need 3,500 hours and you are only allowed 34. So even 31 won't work. How about 32? 32, you need 3,000 hours. You are allowed 3,200 overtime. Other places, you are all good. Hey, I found a slightly better plan. Okay. Can it be any better? I don't know. Let's see. If you did that, you're reducing your laying off 14 workers. Okay. Okay, this is a better plan. We tried 31, didn't work. 32 is what we need. So we found this is mixed strategy. We trial and error. We found something better. Okay. Hopefully this helps you. Thank you very much. Good luck.